All right, let's take a look at the examples that we have. You can see that I still have the notes that we just discussed earlier, keeping in mind that we're trying to find the derivative using the chain rule, keeping in mind that the chain rule is used to find the derivative when you have a function inside of a function. We've established that you first must identify the outside and the inside, and then you can find the derivative. Alright, so this is what we're going to follow. You find the derivative of the outside, leave the inside alone, multiplied by the derivative of the inside. Alright, so let's see how that works. Let's take a look at problem number 1. In problem number 1, the outside function is the quantity to the 37th power. In other words, the power is the outside function. That's what we're doing on the outside. And the inside function is x cubed plus 2x. So we're going to tackle the outside first, and then we're going to tackle the inside. Now, you will not always have to write down on your paper the inside function and the outside function. But I'm doing that now just to show you what's going on and so you get used to the process. But the more you practice, the better you'll get at this. So here we go. The derivative of the outside. Now again, the power is the outside, and x cubed plus 2x is the inside. So if you were to find the derivative of x to the 37th power, that's basically how you're going to treat this. You would use the power rule, so the derivative will be, bring down the power, times, think of it as the variable, times what was on the inside. So that's what I mean when I say the derivative of the outside, leave the inside alone. This is what I'm talking about, leave the inside alone. It just kind of comes along for the ride. We decrease the power using the power rule. Now all of that right there, that entire quantity, that's the derivative of the outside. So I'm just going to write derivative of the outside. Alright, so that's the first step. So we've taken care of this function. Now we're going to multiply by the derivative of the inside. So we're just simply taking the derivative of this function, which is pretty easy. The derivative of that function would be 3x squared plus 2. And there's really no cleaning that we can do. That's simply the derivative. And this piece over here is the derivative of the inside. Okay, let's take a look at number 2. Before we do problem number 2, we're going to have to apply a little bit of algebra to this. And let me get some space here and just change colors. First, I'm going to rewrite this function as, I'm going to bring the expression out of the denominator and into the numerator. We get 3x squared minus 2x plus 1 equal to 5. Right, so in this function, the power is on the outside, and then we have a polynomial, or a quadratic in this case, on the inside. So we deal with the outside first, and since this is a power, we're going to deal with it using the power rule. And that's to the negative 5. Thanks for that correction. Because we brought the power up. So the derivative of this function then would be, use the power rule on the power. Bring it down, we get negative 5 of the quantity and decrease the power to the negative 6. Now, the variable stays the same. The inside function just comes along and we don't really do anything with it. So all of that right there, again, is the derivative of the outside. Then we multiply by the derivative of the inside, and the derivative of this quadratic is 6x minus 2. And again, now what we could do here, I don't have a whole lot of space, but the only thing I would do in terms of cleaning is I would leave the negative 5 in the numerator, I would leave the 6x minus 2 in the numerator, and I would move this trinomial to the denominator and make the power positive. But that's not a real big deal. All right, problem number 3. I'm going to do a rewrite, and I'm going to write this as a power function, x cubed minus 2x plus 5 to the 1/2 power. I have an outside function, and the outside function is the power, and the inside function is this trinomial. Whoops, let's make that number 2. Alright, so we're always going to deal with the outside function first. So applying the power rule, we will have 1/2 of the quantity, decrease the power by 1 to the negative 1/2, and the inside just comes along. We don't change anything at all. That's the derivative of the outside. Okay, derivative out. Now we're going to multiply by the derivative of the inside, which is 3x squared minus 2. That is the derivative of the inside. And again, I'm out of space, as you can see, but to clean this, well, let me go ahead and rewrite it over here. If I were going to clean this up, I would rewrite it as 3x squared minus 2 would be in the numerator, over 2 times the square root of x cubed minus 2x plus 5. And that would be my final answer for the derivative. So this is really not that bad. It's simply a matter of practice. Now number 4 I'm going to leave for another time. What I would like to do actually is to go back up to the problems that we had earlier and find the derivative of those functions, just to give us a little bit more practice. Now your homework tonight is going to focus on algebraic functions and not so much trig functions, but let me do just a couple of those since I have a little bit more time left on the video. Move this out of our way down here. Alright, so let's take a look at the function that we had up here, sine of 2x. Now we've already identified the outside, so this is number 1, and we've identified the inside, this is number 2. So over here I'm going to find the derivative. I'm going to write that small up there. The derivative of the function. So if we come back over here to the outside, if we find the derivative of sine, we get what? Good, cosine. And it's cosine of the angle. So the inside just comes along. This part right here, that's the derivative of the outside. Then we multiply by the derivative of the inside. So this is my inside function, and the derivative of 2x is just 2. And of course, when I write this as a final answer, I would write this as 2 cosine of 2x. Derivative of outside times the derivative of the inside. Alright, in the second problem, g of x, we've identified the outside function. This is number 1. This is number 2. So, if we find the derivative of the outside function, we're going to use the power rule. So we have 2 times the quantity to the first power, and we don't have to write the 1, but I'm just emphasizing that I'm using the power rule. Remember what we said, the inside just comes along. That's basically your variable. It's taking the place of x. And then we multiply by the derivative of the inside, which in this case is just 3. So this was the derivative of the outside. This is the derivative of the inside. And when we clean that up, we get 6 times 3x plus 2, which we can make 18x plus 12 as a final derivative. Not too bad. Let's do one more. I'm going to save the double chain for another day. It's not that bad, but we'll do that another time. Let's go ahead and take a look at this last problem here. We've identified the outside function as cosine, so that's our number 1, and we've identified the inside function as 3x squared. That's our number 2. I'm going to change colors here so we don't confuse with what we've already written. And let's do this. Alright, the derivative of the outside, again, the derivative of cosine is negative sine of the angle, and the angle is the inside function that just comes along for the ride in that step. That's the derivative of the outside. Then we're going to multiply by the derivative of the inside, which is 6x, and in cleaning that up, we would just have negative 6x sine of 3x squared. And that would be my final answer. Alright, so hopefully this has helped you to understand the chain rule a little bit. Again, there is another video posted on my Edline page, one of the Patrick videos, and of course you have your textbook. Your assignment is as follows. It's page 161, 9 through 35 odd, and number 107, and this assignment is on Edline. Tomorrow in class on Thursday, you are going to look at another video on the chain rule.